Okay. Well, Perl has always come at it from the language thing from a natural language point of view, because I was trained more as a linguist than a computer scientist, and some people would say it shows. But with a natural language, you learn it as you go. You're not expected to know the whole language at once. It's okay to have dialects. You can call them DSLs if you want. Other things, natural languages evolve over time, and they don't have arbitrary limits, and they naturally cover multiple paradigms. There are external influences on style. You write poetry different than you swear, I hope. It has fractal dimensionality to it. Easy things should be easy, hard things should be possible. And, if you get really good at it, you can even speak comp sci. So that's natural language, but Perl has always been sort of the same kind of idea. Make some easy things easy for most of the people, but you don't have to be a computer scientist to understand it. It's accessible for mere mortals to begin with, but it hopefully doesn't run out of steam later. So a little background, in the year 2000, we said maybe it's time to break backward compatibility just once and see, maybe we can afford to do that, get off of the worse is worse cycle, crank the thing once for a worse is better cycle. So if you could break one thing, what would it be? And I expected maybe 26 suggestions. We got 361. Another thing that happened about that time was Paul Graham wrote his essay, The 100-Year Language. And he speculated on what the characteristics of a language that might last 100 years are. And, it has to do with whether it can be extensible, whether it can evolve over time gracefully. And so we put a lot of these ideas together and thought really hard. And so we came up with a whole bunch of principles in the last 15 years. There's no most important principle except this one. We want to torment the implementer on behalf of the user. If the error message is less than awesome, we consider that a bug. Every dwim comes with a corresponding WAT. Put that in the corner. Encapsulate your cleverness and then reuse the heck out of it. So all of our pattern matching, what we call smart matching, is all in one table, and every type knows how to do its smart matching, and it's that way consistently throughout the language. The precedence table is another place where there's a lot of cleverness encapsulated in one spot that you just learn. A is a funny kind of a B, but call it A. That's the lesson we learned from Perl 5. I won't go into that. Give the user enough rope to shoot themselves in the foot, but hide the rope in the corner. Okay, every feature should have high leverage, but not too high. Pick the right default this time around. That Perl 5 sort of refrained from picking defaults for object orientation, and that turned out to be a mistake. So you have better defaults. And everything should be strangely consistent. So we got all these things, but the thing we really came up with was, Perl as a culture is postmodern, but there really is no one true language. Not even Perl 6 is the one true language, because Perl 6 itself is a braid of sublanguages, slangs for short, convenient. And they interact with each other, and you can modify each part of the braid. My hair is almost getting long enough to braid now. I never grew my hair out before. I'll have to try that. But a braid of languages. Let me illustrate. Okay, one of the braids of languages is for each of the different slots that an operator can be. So we can redefine, or define, not redefine, a postfix bang operator. We don't happen to have it built in. Wonder of wonders. So if I define it, this should look almost like Erlang to you. It's a recursive function, obviously. But you notice that over here we're actually using the new symbol in part of its definition. The way the slang works is as soon as it sees that name of a new function, it derives a new parser with a mixed-in rule for parsing that. It automatically writes a new Elixir for you. So you never have to write your own Elixir. It writes its own longest token matching. And it's all already available by then. So if I run this here, it actually comes up with... yeah, it does, yeah. We also have, obviously, long, big integers by default. So... and here we have the same thing. Now, a lot of people are allergic to sigils. In Perl culture, we like our sigils, but you can write without them. So here we have the sigilless style here, where we just called our parameter n, and that works also. Or we can talk directly to the dispatcher. We've unified functional programming and object-oriented programming. They're just all functions with different dispatchers. So here, we can actually talk to the dispatcher and say, well, call the same function, but with this argument, and that will also work. But that's not how we usually write. We don't usually write tail recursive things in Perl 6. You'd usually write a reduction operator. This just says, multiply everything from 1 to n. And that works too. And there's a little philosophical thing there, is that even though we're building a lot of functional programming capabilities into Perl 6, this whole head-tail recursive definition of things tends to work against concurrency. We're more of the view of Guy Steele and Fortress, where we want to be able to subdivide things equally, lists. So our lists are a higher abstraction level than necessarily the head and tail of Lisp. So going on, 15 years later, what have we got? Well, we got, in 2015, we got our first real release of Perl 6. So the version number is 6.c, Christmas. The next one will be 6.d, Diwali. But what do we have? We have a fun, handy, scalable, learnable, expressive, optimizable, maintainable. They just keep getting longer and longer, don't they? Multi-paradigm, gradually typed, Unicode-friendly, concurrency-aware, test suite specified, functionally reactive, parametrically, I can't even say it, linguistically malleable, multiple virtual machine, meta-object protocol defined, representationally polymorphic, that's important, thingy. And every one of those things is worth a talk. But Perl 6, we want it to be the last programming language you'd ever want to use. No, that's not. No, we want it to not run out of steam when you need it not to. Okay, but we borrowed a lot of ideas. Haskell, we borrowed the idea of laziness and some other ideas. From Smalltalk and Java, Smalltalk we borrowed the idea of traits. We call them roles instead. But instead of just doing Smalltalk traits for compile time mix-ins, we also added in ideas of interfaces and mix-ins and generics. So that one construct serves all of those kind of things as immutable, reusable bits of code that are not classes. Borrowed some things from Go. We have promises and channels. So if you're familiar with Go, those are functional reactive programming from C# and I guess Erlang. Even have borrowed some ideas from APL indirectly. Not the syntax, of course. But for instance, we have a lot of operators, a lot of list operators, but we can compose meta operators, and this is kind of an idea from APL. Here's just a plain old cross operator. It takes two lists. If you run it, it produces the Cartesian cross product of those. But what if you add a concatenation operator there? It's cross with, so it'll be like zip with, cross with, etc. So this will instead do a cross concatenation of everything. And that's just one of the meta operators that we have. Here's something that's kind of functional programming. I mean, it says, I have a sequence, and here's 1, 2, 3, you figure out the rest of it. And it does. Whoops. But again, Haskell, lazy lists. So it says, I'm smarter than you. I'm not going to try to do that. Or it doesn't matter if you write, that's, by the way, is read 1, 2, 3, ... whatever. The star is usually read whatever. And what it really means is delegate to whatever you're calling to figure out what the appropriate thing there is. But you can have the explicit infinite. You can write it in Unicode if you want. That works too. But what if you actually just want to have part of it? Well, you can slice with subscript. All of these three mean the same thing. We use 0 up to but not including so often as a range that we have a unary operator that does that. So all of these will produce the same sequence. Sequences also know how to iterate on strings, so you can do that. Now, you guys have smartphones, and they're always fixing your quotes to curly quotes for you, and that's frustrating, right? Well, what if you actually type that into? It doesn't care. Curly quotes are fine. How many of you from Europe? How many of you have different curly quotes? Yeah. Well, some of you had these, right? That works. And some of you have the closing curly quotes the other direction. That also works. And what if it actually turns your ... into a Unicode character? Well, yeah, that works too. So we're very up on Unicode here. We process everything in terms of graphemes, like Swift, only better. And we call that normalization form grapheme. But basically the idea is you take any composed character, whether or not it has pre-composed a variant in Unicode, we'll pretend like they're all pre-composed. So those are graphemes. If the native speaker, or here a physicist, he wants vector move. And he wants to think of that as a single character, or she. Well, it is one character in Perl 6. It's 2 code points, but it's one character. Oops. Do that again. It doesn't matter how many markings you have on. In Perl 5, if you say this, it says that's 49 characters. Oh, oops, I forgot to tell it was UTF-8. So we say UTF-8, and it's still 27 characters. In Perl 6, how many is it? It's 5. If you happen to want to write your numbers in Tibetan, that works. Or cuneiform. This just all falls out of Unicode. I mean, they just apply this, so it's trivial to hook it up, really. Vulgar fractions, they work. And you might think, well, that's a floating point number. No, it's not. It's a rat. Has a nice mellow one. And what are the rat's methods? Well, it has lots of rats, including you turn it into a fat rat if you feed it enough. Okay, well, I'd say one of those methods is nude. Numerator and denominator, but you'll never forget the method name. There's got to be a joke about nude rats in here, but I don't know what it is. Or you can get the Perl representation of it. And you see, it's sort of going back and forth here between functional and you can treat everything as an object, much like in Ruby. And this is an exact Perl representation of that value. Keep doing the wrong period. Okay, well, what happens if you, speaking of rats, what happens if you say this? In Perl 5, if you try this in your favorite language, it probably is going to say these are not equal. But in Perl 6, we see that, yes, it is, because those are not floating point numbers in Perl 6. Those are rationals. You actually have to put the E0 on it if you want to do things in floating point. Okay, so since we do things exactly in rationals, does this exactly match its endpoint? Of course it does. try that in your language, and it might not match. It might just keep going on forever. Okay, but we can say, okay, here's one that does go on forever, but give me the first 40 values of it. So you see it into a geometric sequence. And here's another geometric sequence that just happens to have a multiplier of -1, so it can do that one too. And yes, you can just say 2 to the 32 if you want. What it'll do with this? Looks like it wants to be a Fibonacci sequence, doesn't it? Well, we're not that crazy. If you really want a Fibonacci sequence, then you can either name the built-in infix plus operator, that's its actual name, or you can write lambda in any of those 3 ways, and those all produce Fibonacci. So, yeah, we had an earlier talk where we had Fibonacci of 40, and it took a couple seconds to do it. It takes 0.005 seconds in Perl 6 to get the 40th Fibonacci, but of course we're not doing it recursively. More fun. Function composition. Okay, log of a minus number is of course going to blow up, but if we compose it with absolute, then we can get a safer version. Fold operators. You can write reductions in the shorthand that we have, or there's also the longer forms if you need to get fancier. So these all add 1 through 4. Quick, what's the sum of all these numbers? You're right. It's cheating, of course. It's optimizing that to a sum method on a range object, which it knows how to skip over the intermediate values. Here's scan if you in the Haskell terminology. Oops. So that gives you the Pascal numbers. It's triangular because your numbers or your structures tend to get larger and larger, so there's sort of a metaphorical triangle there. So the first, whoops, I keep typing the wrong thing. Okay, so there's the first 40 triangular numbers there. Roll 5 Yahtzee dice here and print them out. Unfortunately, Unicode doesn't actually give the numeric values for those dice, so I have to use the original array. But for those dice, okay, the sum is 15, min's 1. The range is all the way from 1 to 6, and the least common multiple is 12. Because that's an infix operator, we can use it as in a reduction. A few more things to look at. You don't have to specify lfold or rfold because it intuits that from the operator itself, so it knows that exponentiation folds from one direction and multiplication from the other. Automatic identity, if you like to do a large factorial, that's one thing, but what if there's only one thing? Well, you still get 1. What if there's nothing in that? It's still 1 because it knows that that's the identity. If you reduce on a comparison operator, then it. Oops. I made these all variants of the N key, and that was a mistake. Control N is not the same as. Okay. Okay. So I get true and false there. The identity value for that one is true. Identity for min and max is plus and minus infinity, of course. GCD. I don't know what 0 argumenting for GCD. Okay, other meta ops. We saw X earlier. Suppose we define our own beta operator here, which puts a bow tie. So that puts the arguments in reverse. This does a zip. So it does in parallel, zip width basically. The X we already saw does the cross. You can stack them, so it's the reverse X. Yeah, you could have an operator that's 500 characters long if you wanted to. No arbitrary limits. There's X reverse, which you notice is actually different. If you do reverse X reverse, it comes back out to the same thing. So, just to sum up quickly, we do a lot of stuff with concurrency now in Perl 6 that will look very familiar to Go and Erlang programmers. The structure of the scheduler threads versus what you call processes is quite similar. Reactive programming is a new thing where you can write things that look like loops, but they do the right thing and compose with reactive responses to things. And just to kind of stop on this one, one of the important things that we do now is called representational polymorphism. And that means that even your classes in Perl 6 don't actually care what the representation is. So you write your class the same way, your methods the same way, your accessors, and it doesn't care whether it's the built-in opaque type or whether it's some VM array of underneath or a C structure or C++ or a Python object or a Ruby object. Those can all look the same. So that makes it very easy to interoperate with any other languages that we can talk to. That's probably enough. Probably too much.
No, I'm very impressed.
Yeah.
Just thinking how we will be cursed in
200 or 300 years' time with all these programmers who have to read legacy Erlang and legacy Perl, and they go, what is like? It'll be like the ancient hieroglyphics.
Yeah,
nobody will dare change it because it all works. And they'll be going, oh, who are those horrible people who did this to us?
Fortunately, I'll be dead.
Yes. And also, if you design languages, of course, you get no credit for all the programs that work, but the odd program that's been written in your language which fails, it's your fault.
Of course, yes. One of the things we started out with when we decided to break things and come up with Perl 6 was, we already know what our old mistakes are. Let's throw those out and make new mistakes this time. But kind of related mistakes in the sense that Perl as the overall philosophy of how you think of programming as an activity embedded in a culture, and that the culture says a lot to how you actually structure the style of your program, and externalities will often determine whether you want to be object-oriented or functional or do logic programming or what have you. Just as in a natural language, if you take a class in poetry, you're going to produce works of literature that hopefully look and work like poems. But if you take a math class and write a math paper, it's structured more like a math paper. But in each case, and in all sort of literary works, it's this negotiation that is happening between the writer and the reader, whether that reader is a computer or the next programmer, who's going to read your code and is an axe murderer. There's this negotiation of here is I'm starting off sort of with an understanding of my cultural dialects here, but I switch into more and more specifics about exactly what language I am programming in. And the big idea in Perl 6 is that, unlike Perl 5, which was always really confused about what language it was parsing, and So don't ever try reading its parser. You'll go mad. Perl 6, in contrast, that's one of the mistakes we decided we'd never make again. Perl 6 always knows exactly what language it's parsing, and a strict one-pass parsing, like Pascal. And at every point, it can drop in, when you define a new operator, or you pull in a new slang, or if you say use COBOL, it just drops into that different language, and it might or might not be related to the outer language. It drops into the parser for that language as a pure parser that knows what to do with that language, and then at the end of that block, or subprogram, it comes back out and it restores back to the previous lexical scope. So lexical scopes are very important for knowing exactly what language you are in. And we never cheat by looking ahead and seeing what classes are declared. We don't even know what the class declaration will look like at the end of the program necessarily. We might be in a completely different program. So we don't cheat anywhere in Perl 6. So it's very clean linguistically. And this buys us a lot of power that we think will eventually control that divergence that happens to all languages. Either your language is too brittle and people just invent different languages that do the same thing with different syntax, or your language is too mushy and it just becomes a mess, kind of like some Perl 5 did, unless you're disciplined. So to avoid either of those big mistakes, we have this, just as Erlang is very strict about its process model, we are very strict about our linguistic model. And so we think that will help us over the long term to be more like what Paul Graham was talking about when he talks about a 100-year language.
So in preparation for having a conversation with you, I was looking on the internet for quotes of yours and things like that.
Oh, quotes. Well, I'll say anything.
No, but and then I discovered that you're 1 year older than me. So you obviously
I'm not sure that I'm a year wiser.
Much more well, I was going to say you're much wiser than I was, but it meant that we've been through the same shift in generational shift in hardware. And what's always kind of puzzling me is where did we go wrong? Because there are certain, in my mind, certain dimensions of computers are kind of fixed in my memory. So one limit that took a long time to break was this 1.44 megabyte limit of a floppy disk.
Yeah.
And for a long time, development increased to the point where you got to 1.44 megabytes and then you stopped.
I had a smaller limit than that. When I was first sending out programs, Usenet articles could only be 32K characters.
Right.
So if you wanted to send out software then, you had to have a little program that would split your program up into separate files that could then be glued back together.
So I remember Tom's recovery disk,
yeah,
which had a complete Unix kernel and everything on a 1.44 megabyte floppy disk. And I remember some Erlangs we did that it was essential they fitted into 1.44 megabytes. And then things started to change, and these went away. And suddenly you're not aware of that anymore, and you go into the future and you look back and suddenly you say, what, the perception that an operating system is, a small operating system image is a few gigabytes or something like this. So where do we go wrong?
Well, we're not wrong. We're just displaced because our normal machines are getting bigger and more powerful. But this whole Internet of Things, we're gonna you're not gonna put a huge computer inside of a light bulb.
Well, you're going to put a Cray 100 times the power of a Cray 1 into it.
Run the CPU hot enough, it could just be incandescent, I guess.
But it's going to be it's more powerful than a Cray.
Probably. And that's part of why I did not worry too much about making a large language in Perl 6. Obviously, the larger your language, the harder it is to port. And we do have a portability layer of a restricted subset that does make it easier. But one worries a little bit about making it too hard to put onto different VMs. We currently run on our own VM, which is called More VM. Historically, we used to run on Parrot VM. We have been on C# and on Haskell. Those are all prototypes that have sort of gone away. We also run on the JVM currently. So we've got a story about portability.
But I'm more thinking in when we have megahertz clocks.
Yeah.
Why isn't an operating system booting in 2 or 3 microseconds? That's because
well, yeah. Well,
I mean, as Alan Kay said, you do have to reinvent everything.
Computers are getting more and more like people, and so the principles that apply to people are starting to apply to computers. And this principle is every computer will be promoted to its level of incompetence. And artificial intelligence is going to start looking like natural stupidity. So I'm sure that even if the singularity comes, well, I think it's probably going to be a plurality, not a singularity. But I think the foibles that we have as humans, the computers will just make the same mistakes faster. So.
And of course, the other effect is if you go back to the mid-'80s, that programmers could talk to each other. Because everybody, even if they knew different programming, everybody knew C, everybody knew Make, everybody knew Bash. Mm-hmm. And nowadays they can't talk to each other. I mean, what builds the? Oh, I'm using Groovy on Grunt. My Grunt doesn't work. I haven't installed all these things.
Yeah. While I was coming in here, I said, "Does OTP still mean what it used to mean?" We are in the process of becoming fossils, and the new culture will always be built up on the strata of the old. So it's a healthy process that the new generations will take what they can from us old geezers, and take what they like and leave behind some of the things that maybe they don't like so much. But
because now I think. When we started programming, presumably the same for you, when you're learning programming, you had the choice of learning assembler, COBOL, or Fortran.
I learned BASIC.
Oh, right. I don't think we had machines that were that advanced.
Yeah. Actually, my first computer program was on a programmable calculator that's not even, I think it's Mayfair or some off-brand. You could program it with 120 steps that were like key presses. And I almost got tic-tac-toe into 120 steps, but I'm sure it was a very stupid program, and if I could do it now, I'd probably do better. But no, but actually my first computer language was BASIC Plus on a DEC Ristus machine.
So when was that?
1972. It was actually on a PDP 1120, which was a forerunner to the PDP 1145.
So you hadn't done any programming before that at all?
Only on this, only in my last quarter of high school, that when we got this new calculator, and I was supposed to be doing independent study in math, and most of my independent study was on the calculator.
So I started with Fortran
Yeah.
in 1968, I think, and there was a 3-week turnaround time for your program because.
Exactly, yeah.
The first week you did it on the coding forms, and then you sent it off. And then
I did have to do COBOL in a batch system. We had to take our card decks down, and of course I never got a clean compile. But on the other hand, I didn't really study all that much. Instead, the night before the final, I read the entire IBM COBOL manual and aced the test. But But there's lots of people talk about COBOL. COBOL has had a good run, and I do have to sometimes disabuse people of the notion that if a programming language is like working like a natural language, they immediately think of COBOL, which sort of cargo culted phrases in without really doing anything. It was really just a procedural language that happened to have English phrases as keywords, but it didn't really work like natural language on a deep level. I knew COBOL was not for me as soon as I saw you call a subroutine, or you say compute, you say what you don't even call. Why don't you do a subroutine? That's 2 letters. You have to. How do you invoke? I forgot.
I don't know.
Call using or something like that.
Yeah, there's like a 7-letter word for calling a subroutine. And I said, why are they using long words for common stuff? And this is the beginning of this inkling that, if you're going to use something frequently, it should get rubbed down and be the short things. The term we use nowadays in design is Huffman coding. Now, Huffman coding is a bit encoding that where frequent characters get a small number of bits and less frequent characters get many bits. But the metaphorical meaning of that is, make the common cases short. And this happens in natural language too. If you look at almost any natural language, the most irregular parts of the language will be the most commonly used verbs and nouns. And that's because that is where you use them the most. You need the most irregularity there for information density and clarity and redundancy of communication, so that it's not really surprising that the most irregular parts of natural languages are the most frequently used and the most rubbed down bits of it. So similar things can happen in computer language.
I'm also wondering, at what point in time did you at some point in time say, I know what I'll do, I'll make a new programming language? Or, I never did that.
I did my first real language. Well, I did a toy language for a compiler class with the Dragon book.
Yeah.
I mostly ignored the Dragon back. I mostly ignored the Dragon book and used Yak. Yeah, that's okay. Al Aho and I are friends now. He's a great guy. One toy language, and then I had this problem that I was programming for our school, our computer center, in Basic Plus, doing real work for the college, and I needed to be able to sort of link in various basic routines. So I needed a kind of an inside-out language. Nowadays, for an inside-out language, you think of something like PHP, where it's mostly text, but then there's sort of code interspersed with the text. This was a different language, but you could intersperse lines that would control how the text was used. So it could basically selectively link in different routines, and this was called JAM, which was a jury-rigged all-purpose meta language.
I did a JAM. It was Joe's Abstract Machine.
Yeah, there too. Yeah, but that was actually my first compiler. That was just a recursive descent kind of thing.
But at that stage, it's to scratch your programming itch. It's not.
Yeah.
It's not the notion that lots of people are going to use this thing.
Yeah, but then I went to work in actual industry after some grad school, and had to do a compiler in Pascal for a discrete event simulator. And I wrote some macro systems for the RN program that I had written, and so I sort of had this general feeling that I could do this sort of thing, and I had published things before, the RN program, the patch program, which does a certain amount of parsing. So I already had this kind of inkling that I like writing compilers, and that if I like something, other people might like it. So when I sort of had this realization that Unix had this gaping hole, you could do shell programming, which was, you could whip things up. I call it whip-uptitude. And you had C programming, which was very intricate, and you could do anything. I call that manipulexity. If you think of that as either or, then you just program in one or the other. But I realized it was two different dimensions, and it opened up as kind of a two-dimensional graph. And I realized there's a big hole out there where something that you could whip stuff up in quickly, like shell, but that could do more intricate things than shell programming could do, and work more like an actual programming language. Even though that kind of was a violation of Unix philosophy of do one thing and do it well, it actually ended up being a toolbox such that people could then make other tools and kind of fit back into the toolbox. So, I was already on my, my rebellious slide into changing the world at that point, not everyone in the Unix community appreciated that. I think Henry Spencer famously called early Perl awk with skin cancer. I think it was ugly.
I think I called it transmission line garbage.
Well, but it can be written to look like that. But with discipline, even Perl 5 can be made.
Because I remember reading your Perl book,
yeah.
I like the first thing.
With Perl 6, you'll discover you can actually write some beautiful code with it.
But I was kind of irritated by the way you started off with I think it was a character counter or a word counter or something like that. And you wrote it more or less as I would understand in C or something, with a while loop and getting tokens. And then you say, we can omit these brackets and we can remove these arguments. And the program just got shorter and shorter and shorter. And I thought, dear.
Yeah, well, I did a couple years win the obfuscated C code contest.
I saw that, yes. What did those programs do for you?
One of them was a Dvorak keyboard emulator. So
Right.
you ran it and started typing and it translated all the characters. The other was a Roman numeral calculator that looked like it was all written in Roman numerals.
Right. So were these techniques you used when you implemented in the source code of Perl?
Two of them. When I started working on Perl 6, and we, as a community, we were starting to decide how to divvy up all the work. The people who were with it said that we will implement Perl 6. You stay out of the implementation. You are just the language designer, because we see what the insides of Perl 5 look like. And we don't want the inside of Perl 6 to look like that. Which was funny, because it sort of ended up doing the same thing. You can't program in C without writing a bunch of macros.
So did you keep out of it, or you poked
I
it
did
around?
actually keep out of it, and that's part of the reason that we had, I suppose, 3 or 4 prototypes that didn't really work. We learned even the failures, though, we learned a great deal from each of them. Each person who tried to implement Perl 6 and had different ideas about it, they taught us, different ways to think about things. The first implementation was actually in Haskell, and that really tightened up a lot of our thinking about.
So did you remove a lot of stuff as well as adding stuff? I mean, from the ideas you had?
From Perl?
Well, no, I mean, from Perl 6, first of all, as a designer, you say, I think we'll do that and we'll do that. And then it just becomes so complicated to implement that you remove it.
Well, we were kind of careful not to put in things in the first place that we didn't think would be quite useful. What we did discover along the way was that many things that seemed like separate things on the surface ended up unifying underneath. So it turned out to be really easy to get most of functional programming and most of object-oriented.
Because like Nicholas Viert said,
In the
every time you add something to a program language, you should take something out in order to, so that it
Yeah,
remains
I mean,
simple.
I freely admit that you are more of a minimalist than I am.
So I keep wanting to take things out rather than put things in.
And I need the minimalists running alongside my chariot saying, "You are mortal." So I have great appreciation for the idea that of trying to keep things simple as possible. Where I think it sometimes goes wrong is the full phrase is keep it as simple as possible, but no simpler. And real life is not simple, and the problems that are presented to computer science to solve, some of them are they're math problems. They work great in functional programming. Some of them are simulation problems, and those tend to work better with object orientation, logic, however you slice up your paradigms. Quick and dirty scripting. There are languages that excel in each of these areas, and one can achieve a certain kind of purity. I suppose even in the PHP realm, there's some kind of purity that they are achieving. But when you start looking at a language that wants to encompass the whole world, like English, it doesn't have to be perfect at everything. But if you can do 90% of this paradigm and 90% of that paradigm and get those talking to each other underneath in a smooth fashion, that's what we think we've achieved with Perl 6. If you scratch a method, it's really just a function. It just has a different dispatcher that says how to find it and call it.
Yeah, I see Francesco's walked in, and I think there are drinks afterwards.
Okay.
And we could actually sit here talking forever.
We could.
We could.
We
could, yes.
Yeah. Let me just make one final point, though. The main thing that I think we've really got in from functional programming is the idea of a coherent type system. Perl 5 had an incoherent type system, and so the computer was often just as confused as the programmer is to the type of a thing. With Perl 6, we don't really have types for the benefit of strong typing. It's more like that's third place. Second place is we can optimize better. But first place is actually it's there for multiple dispatch and pattern matching, to use more your term. And this pervasive pattern matching and multiple dispatch, whether it's to methods or to functions. I mean, you saw it there with the postfix example, is built in at a fundamental level, and that's why Perl 6 loves types, is to drive that. And it actually, once you've done your multiple dispatch and decided which thing to call, you don't even have to check your function arguments. You've already checked your function arguments to do this dispatch. So in a sense, dynamic type checking comes for free as soon as you've done that. So that is another thing that I want to thank the functional programming community for letting us steal. In some sense, we have our separate communities, but we're all, one big community, and we're all trying to get similar things done. And going back to anthropology, there's people who live in one community, and they tell the stories of that community and the tribal leaders there. But there's also the merchants that go back and forth between different communities. And healthy cultures need both of those things. So it actually pleases me to see, Erlang and Elixir sharing a conference like that. Perl has shared with the Ruby community over the years, especially in Japan.
Yeah, because of course we don't build systems with one language. We use lots of
And
languages.
so, our slogan, there's more than one way to do it, that applies outside of Perl as well as inside. So I think this is great. And I thank you for inviting me. And
Well, thanks for coming. That's good.
We'll take 2 questions, one for each language inventor. Any questions? No?
any kvetchings?
When is it?
So,
There's 31% more on there.
well, let's see then. Metaprogramming.
Would Perl ever be put on the beam?
It needs a champion. Maybe that will tickle one of you guys. We definitely have tried to make it possible to put our language onto different VMs, and it does run on JVM, and JavaScript is nearly done. If you can put it on JavaScript, you can probably put it anywhere.
Any other questions? No? Okay, great. Thank you very much.